read yet in your class? Oh man. The unit circle we did in our last class. You didn't do that also in your class? Okay. So, what do you prefer? Me keep doing my job, like going ahead of what I have in my schedule, or you want a break and then catch up with the lecture and then I'll do the recitation after he done with the lecture materials. Great.
Great. Maybe because I'm confused on the whole certain thing still.
Okay, then let's do this. I heard that I'm two lecture ahead of your lecture instructor. So let's not meet on next week. Next week you can have it off because I'm already ahead. And then probably by next week he will go to Trig and then complete the unit circle with you. And also you're going to know more about even and add functions and all these things. So today I'm going to complete this, but next week you don't have to do anything. Catch up with the lecture materials, have fun, enjoy, and then you're going to meet again following week. And when you come back, we're going to do week 9. Okay? Do you know, is he teaching this class for the first time? No, he looks like a
He said he was tutoring before.
So this is his first time teaching this class.
I don't know. We'll ask him next time.
Because mostly the first time are always. I was the same thing when I taught for the first time. So that's like, why is so behind? There's definitely one reason. Because keeping up with the time is very hard. Our instructor, not instructor, say our coordinator, she actually did everything for us. The lecture notes, the example is supposed to go, all these things, recitation, everything was pre-set up. We are just here to deliver the lecture. And in the lecture, every day he has to cover so many materials. And probably that's why he's behind, because he doesn't want to rush. He wants you to learn the materials instead of just completing the syllabus. But yeah, he's a nice personality. On my case, the only thing I can do is give you a break, because we do have to complete all of these 14 recitations. So since I'm going to need one recitation, that means at the end you're going to do 2 recitations by yourself. And I think you'll be fine as long as he covers the lecture in the lecture section. Any question? Any comments? Concern? Complaint? Anything, nothing? Okay, so today we are going to do more trig, and I'm going to tell you few important things. The first thing is being odd or being even. So we all know that we have 6 trig functions, right? What are they? Do you know? Do you remember? So among all 6, there are only 2 functions that are even. What does even mean? Even means it doesn't matter if you replace your x with positive number or negative number, it's always positive. Okay, this is what being even mean. So not always positive. Here's the definition. If you replace your x with negative x, you get the same as original function back. For example, y equals x squared is an even function. Why? Because instead of y, we mean f of x. F of x equals x squared is an even function. because it doesn't matter what you replace your x with, the result is always the positive number square. For example, if you have x to the -1, it's -1 square, give you +1. If you replace x with +1, it's 1 square, give you 1. Or if you replace x with, let's say, -5, it's -5 square, 25. If you replace x with 5, it's 5 square, 25. So it doesn't matter what you replace your x with, it's always the positive and negative x value gives you the same y value. Okay, so this is what being even means. You can replace your x with positive number or negative number. You always get the original function back. They give you the same result back. So among all these 6 trig functions, there are only 2 functions that are even. One of them is cosine x. Look at the cosine graph. It starts from 1, goes down, goes up on both directions. So what we have on the left side, we have the same thing on the right side of the y-axis. So this is cosine of x. So left and right, they give you the same result back. It's an even function. And whatever is connected with the cosine, that must be also even function. So what is connected with cosine? Do you guys know? You don't know? Okay, I'm going to tell you that. In order to tell you that, let's do question 4 first. Okay. Question 4 said, write all those identities for reciprocal and quotient. So for quotient, let me start with the reciprocal. For reciprocal, there are 6 of them. Sine of x is 1/, cosecant of x. So sine and cosecant, they're connected. Cosine of x is 1/, secant of x. That means cosine and secant, they are connected. Tangent of x is 1/, can you guess? 1/, what? Secant, we already used secant. We already used sine. Sine and cosine, they are connected. Cotangent, the only thing we did not use is cotangent. The sine is connected with cosecant, cosine is connected with secant, and tangent is connected with cotangent. See, they are the same name, tangent and cotangent, so they are together. And we have the other way around. Cosecant, cosecant of x is 1/, sine x. Secant of x is 1/, cosine x. So they are reciprocal of one another. Bless you. And then cotangent of x is 1/, tangent of x. If A is reciprocal of B, that means B is also reciprocal of A. So that's why sine is the reciprocal of cosecant, cosecant is the reciprocal of sine. So sine and cosecant, they are connected. Cosine and secant, they are connected. Tangent and cotangent, they are connected. And then we have 2 more extra for quotient identities. Quotient means division, right? We get quotient by dividing something. So for quotient, we take tangent and cotangent. Only these 2 have the quotient identities. It says tangent x is 1/, cotangent, correct? Also, it's sine of x divided by cosine of x. That means since cotangent of x is the reciprocal of tangent, can you guess what will be cotangent, what over what? Good job. Cosine of x over sine of x. So these two are quotient identities, and we have 6 reciprocal identities. Now, previously I told you that for even function, among the 6 functions, only cosine is even, and something, the function that is connected with cosine. So which function is connected with cosine? Secant. So our even functions are cosine and secant. Are you guys done with number 4, or you need more time? Do you need more time? Okay. I don't know the graph for the secant, okay? I only know the graph for the cosine. So the graph for the cosecant, it could be similar where you have left and right same of the x-axis. So not x-axis, y-axis. Okay, so if only these two are even function, can you guess what are the odd functions? So start with sine. Sine must be odd function. And what is connected with sine? Cosecant. And then cosine and secant, they're connected, they're even. So left with tangent and its relative cotangent. So these 4 are odd function and the rest are even function. Odd function means if you replace your x with negative x, you get negative of the y value. So you change your x from positive to negative, your y also changes from positive to negative. This is what it means. Any question? Why it's odd is hard to explain. Why it's odd. I can tell you how it's odd. The only way we determine is by using the definition. This is the definition of being odd. You can find out whether any function, any type of function is odd or even by looking at the definition. This is the definition for odd, and this is the definition for even. F of negative x gives you the same f of x back. So being even means you replace x with negative thing, you get the positive thing back. Being odd means you replace x with negative x, you get the negative of the y value back. Now, let's do one example. How do you know something is odd or something is even? The question you asked me. Question 3. They gave us a function cosecant square plus secant plus cosine cube. Now, we know the original cosecant is odd, right? Without any power. Secant is even. Cosine is what? Odd or even? Even. So individually, they are odd, even. Now the question is, if you put them together, what do we get? An odd function, even function, or something that is neither odd nor even? Okay? So to figure this out, all you have to do is replace all the x you see with negative x. But before doing that, let's rewrite. Cosine square x is same as, not cosine, cosecant x whole thing square. You can write either way. The power you can put on the trig function, or you can write the entire trig function first, and then you can put the power. They're exactly the same thing. Secant doesn't have any power, so let's leave it alone. And cosine has a power, so let's write the cosine whole function first, and then put the power. Why I did that? Because if you do that, you can easily replace the x with negative and then figure out what the outcome is. So in order to figure out whether they're odd or even, we look at we replace all this, and this. I didn't do that. Come on. Here. All those excess with negative x. So let's do that. Cosecant square secant cosine q, and we get negative x, negative x, negative x. Every x you see, replace them with negative x. So we have f of x here, and this should be f of negative x. And now let's simplify and see what happens. Cosecant negative x, all things squared. The cosecant is an odd function, right? For odd function, if you replace your positive x with negative x, then it says negative of the original function. Right? This is the definition. Are you here? If you replace your x with negative x, you get the negative of the original function. That means cosecant of negative x gives us negative of the original cosecant x function. Because this is what being odd means. If you replace x with negative x, you get negative of the y back. So the original y as a function of cosecant x, when you replace cosecant with negative x, you get negative and then the original function. Secant is an even function. Even function means if you replace x with negative x, it doesn't matter. You can replace x with negative x. You get the same original function back. No sign changes. So what do you get from secant negative x? Secant of positive x. Because it's even. And cosine, is it odd or even? Even. So cosine of negative x gives us what? Cosine of positive x. This is what being even means. The sign doesn't do anything. You're always you. You face all the negative things in your life, but you still just same it yourself. You don't change. And odd, we say odd people. Why do you call them odd? Because they're not normal, right? They're not even, like they're odd. They do odd stuff. So like here, you give a negative x, they put the negativity in front of them. That's why they add. Okay, now you're going to work with the power. If you multiply negative twice, what do you get? Positive. So from here, we get cosecant x squared. Because the negative turns into positive. Secant doesn't have anything. And cosine x cubed has no problem. Now this function and this function, we compare these two. Our first line is the original function, and after we replace x with negative x, applying the power and everything, what do you notice? It's the same thing. So what did we just figure out? F of negative x gives us what back? F of x. The same original function we get even after replacing x with negative x. So whatever function is this? Odd or even? Even. That's how we find out whether any function is odd or even. It could be trig, it could be polynomial, it could be rational, it could be any type of function. All we have to do is figure out replace the x with negative x, and figure out what's the outcome. And yes, in your exam, you're supposed to have one example where you're supposed to find out which of the function is an odd or even function. So this is the exam question. It could be trig or it could be polynomial. I'm not sure. Definitely one in this topic. Any question? Was anything unclear, confusing? Nothing? Can I change my slides? Is everybody done? Okay. The next one says we are given more than one trig functions together, either they're multiplying or they're dividing. Now write all of them in terms of sine and cosine and simplify. Simplify the following. Whenever we try to simplify any type of trig function, it's always easier to rewrite them using sine and cosine. And I can always do that. Now from this form, which one looks bad? Anyone? Which one? B, C, D, A? Which one? A or B? Okay. Yeah, let's do both. And C and D you can do by yourself. But actually, let's do C and D, B and D. Because A and C are easier. Oh, and actually B is the easiest. Never mind. A and C? Okay, let's see. They're same. Let me do A and D. Okay. So remember I said rewrite everything using sine and cosine. So cosine. In terms of sine and cosine, what is cosine? So that's cosine, secant. In terms of sine or cosine, how do you rewrite secant? What over what? 1 over cosine. And we have big division sign. And how do you tangent using sine and cosine? Using sine and cosine. It's the quotient identity. 1 over cosine. Actually using sine and cosine. See, tangent is sine over cosine. You can use cotangent, but it doesn't help you. Whenever you simplify, your goal is to use sine and cosine, only these two functions. So it's sine of x over cosine of x. Now, do you have any problem up to here? Any question? I did nothing. I just rewrote them using sine and cosine. That's it. And now, what do you observe? Use the cross out. But before doing that, let's do change flip, because it's a fraction over fraction. We don't know how to divide fraction. Instead, we multiply by the reciprocal. So we keep the numerator fraction, change the division sign into multiplication, and we flip the denominator fraction. So it's keep, change, flip expression. So we have 1 over cosine of x, we keep it. We change the division into multiplication. And if we flip the denominator, what do you get? What over what? Cosine over sine. And now what do you observe? We cancel cosine, cosine. We left it 1 on the top, sine on the bottom. And what is 1 over sine? Identity. Cosecant of x. So you can leave this if they said, oh no, they said write a single trig function. So don't leave this because this is a fraction. You don't want to have a fraction as an answer. You want a single trig function. Cosecant is a single trig function. Any question? Same thing. All you have to do is rewrite. What is cotangent in terms of sine and cosine? Cosine over sine. And then we have our sine. We don't need to change that because it's already in sine form. So if you don't have sine cosine, you rewrite using sine and cosine. But if you already have them, don't change them. Keep them. And then what do you observe? Sine on the numerator, cancel the sine on the denominator, and we left to it only the cosine function, which is a single function. So, you're done. Are you guys still with me? Any question? Financing? No questions so far? Do you think you can do B and D? D cosine, let me see. Cosine over sine, cosine over sine, and then we have sine. Okay, let's see the next page. In the next page, we have to do one combining and one proving. So I'll do one, you'll do one. Which one looks best? Combining them or proving the identity? In both cases, we're going to use this identity, cosine square plus sine square equals 1. Six? Okay. So in 7, what you're going to do in 6, you're going to be similar thing on 7. And then you compare left side with the right side. If they're same, you proved it. So let's do 6. It says rewrite as a single trig. So you're given 3 trigs. We want to combine them to become the one single trig function. So let me start here. Cosine of x plus sine square x so you have a fraction and you're adding a non-fraction. In order to add fraction, what is our requirement? We must have to have what? Anytime you're adding fraction, what's the requirement? Same denominator. So what denominator cosine has? 1. Do we have same denominator? So if you're looking for same denominator, what denominator you want on both? Cosine. That means you need to multiply top and bottom by cosine x. So that you can have the same denominator and you can go ahead and do the next step. When you have the same denominator, we write the denominator once. And then what do we do? Combine the numerator, right? So first numerator, how many cosine you see on the first numerator? So cosine x times cosine x. What's the answer? Is it 2 cosine x or cosine squared x? Which one? Good, cosine squared. 2 cosine you get when you add things. Cosine x plus cosine x, that will give you 2 of them. But when you multiply the powers. So 1 power, combination is 2 power. So the first numerator becomes cosine squared x, and you already have our second numerator, so you leave it alone. Any questions so far? Was any step unclear, confusing? Is it a single trig function? That means you cannot stop. Since you cannot stop, we look for more methods. The hint they gave us is anytime you add the squares of sine and cosine, the result is 1. So what is cosine square plus sine square? 1. So I get 1 over cosine x. And what is 1 over cosine x? Secant x. And now we are done because secant is a single function. See, that's all you have to do. And you're going to do the very same thing on the next problem, question 7. Multiply top and bottom by something. So you have the same denominator, combine the numerator, it will turn into 1. Any question? Comments? We have the sign-in sheet. Oh, still moving around. Okay, try 7. And I think you'll be able to done everything today because you have to do only 2 from the first page and 2 from here. So you can submit before you leave. And people who came late, do you have any old recitation to submit from 1 to 7? If you do, please submit them.
But
Yeah, for that.
I'm forgetting something there.
Do you have it in person?
I do.
So anything you did not submit on Lumen, you can submit them today. Oh man, I didn't notice it. I'm so sorry. Thank you so much. Thank you. Recording.